What if I told you that the greatest scientific breakthroughs in history were not made by superhuman geniuses, but by ordinary people who simply refused to stop asking questions? What if the difference between someone who changes the world and someone who doesn't is just curiosity? A child looking at the stars and asking why, a student staring at a strange equation and wondering, how does this work? The universe is full of mysteries, but the most powerful tool we have to uncover them isn't a giant telescope or a particle accelerator. It's the human mind. And one of the scientists who understood this better than almost anyone else was Richard Feynman, a physicist who believed that ordinary people driven by curiosity could uncover the deepest secrets of reality. When we think about physics, space, and the universe, we often imagine towering laboratories, brilliant professors, and complicated equations that seem impossible to understand. Science can feel distant, like something reserved for a small group of extraordinary minds, but the truth is much more inspiring. The history of science is filled with people who began exactly where you are right now, curious about how things work. Richard Feynman often spoke about this idea. He believed that the spirit of science wasn't about memorizing formulas or appearing intelligent. It was about curiosity, wonder, and the courage to explore the unknown. According to him, the universe is not a puzzle designed only for experts. It is an open book waiting for anyone brave enough to ask questions. And when we look at the history of physics and space exploration, we see something remarkable. The discoveries that changed our understanding of reality often started with simple observations. Someone noticed an apple falling from a tree. Someone watched the planets move across the night sky. Someone asked why magnets attract. Someone wondered what light really is. From those simple questions came theories that reshaped human civilization. The universe, it turns out, rewards curiosity. To understand why this idea matters so much, we need to step back and look at the story of how humans began exploring the laws of nature. For thousands of years, the night sky was humanity's greatest mystery. Ancient civilizations looked up and saw stars scattered across the darkness. They saw planets wandering across the heavens. They saw comets appearing without warning and disappearing again. At the time, these phenomena seemed supernatural. People believed the sky was controlled by gods or mystical forces. But then something revolutionary happened. A few individuals began asking a radical question. What if the universe operates according to rules? This idea transformed human history. Instead of simply observing nature, scientists began investigating it. They built experiments, they developed mathematics, they searched for patterns, and slowly, piece by piece, the hidden structure of reality began to emerge. Centuries later, physicists discovered that the universe is governed by fundamental laws. Gravity pulls objects together. Energy cannot be created or destroyed. Light behaves both like a wave and a particle. These discoveries revealed something astonishing. The universe is not random chaos. It is an elegant system of patterns and interactions. But discovering those patterns required a certain mindset. It required people willing to question everything. This is where Feynman's philosophy becomes powerful. He believed science was not about authority or status. It was about doubt, exploration, and excitement. He often said that the joy of science lies in discovering something new, something that nobody has ever understood before. And the incredible part is that many groundbreaking discoveries came from people who simply followed their curiosity. Take the mystery of atoms. For most of human history, no one even knew atoms existed. Everything around us seemed continuous. Water, air, stone, metal. But some thinkers wondered whether matter might actually be made of tiny pieces. It was a bold idea, and for centuries, it remained just a philosophical guess. Then experiments began revealing strange clues. Chemists noticed that elements combined in fixed proportions. Physicists discovered tiny charged particles inside atoms. Eventually, scientists realized that atoms themselves were not solid spheres but miniature solar systems with electrons orbiting a nucleus. Inside that nucleus were even smaller particles, protons and neutrons. And inside those particles were even more fundamental structures called quarks. The deeper scientists looked, the stranger reality became. Quantum physics revealed that particles can behave like waves. They can exist in multiple states at the same time. They can influence each other across vast distances through quantum entanglement. To someone unfamiliar with physics, these ideas sound almost magical. But they are not magic. They are simply the result of ordinary people investigating extraordinary questions. One of the most fascinating aspects of the universe is that simple curiosity often leads to revolutionary discoveries. Imagine a young student wondering how magnets work. That curiosity could eventually lead them to study electromagnetism, one of the fundamental forces of nature. Electromagnetism is the invisible interaction between electric charges and magnetic fields. It is responsible for electricity, radio waves, light, and the technology that powers our modern world. Every time you turn on a smartphone, connect to Wi-Fi, or watch a satellite broadcast, you are witnessing the power of electromagnetism. But when scientists first discovered these forces, they had no idea how important they would become. They were simply curious. They wanted to understand why a compass points north. They wanted to know why lightning flashes across the sky. From those questions emerged entire fields of science, and this pattern repeats throughout history. Curiosity leads to exploration. Exploration leads to discovery. Discovery transforms the world. Feynman believed that anyone capable of curiosity could participate in this journey. You don't need to be born a genius. You only need to ask questions and follow the evidence. Consider the story of space exploration. Just a few centuries ago, humans believed Earth was the center of the universe. The stars were thought to be fixed lights embedded in a cosmic dome, but astronomers began noticing strange patterns. Planets sometimes moved backward in the sky. Their motions were not perfectly circular. Something about the old model didn't make sense. By carefully observing the heavens and applying mathematics, scientists eventually realized that Earth was not the center of everything. Instead, our planet was orbiting the sun. This discovery shattered centuries of belief and opened the door to modern astronomy. Later, physicists discovered that the same force causing an apple to fall to the ground also keeps the moon orbiting Earth and the planets circling the sun. That force is gravity. Gravity shapes the structure of the universe. It pulls gas together to form stars. It binds stars into galaxies. It bends the path of light near massive objects. And when gravity becomes extremely strong, it creates one of the most mysterious objects in existence, black holes. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape. They form when massive stars collapse under their own weight. For decades, black holes existed only as theoretical predictions. But scientists kept asking questions. Could these objects really exist? What would happen near them? How could we detect something that emits no light? Eventually, technology advanced enough to provide answers. Astronomers observed stars orbiting invisible objects at incredible speeds. They detected powerful bursts of energy coming from regions where matter was falling into gravitational abysses. And in 2019, humanity achieved something once thought impossible. Scientists captured the first image of a black hole's shadow. This achievement required telescopes spread across the entire planet, synchronized with atomic clocks and connected through complex data processing. But the idea began with something simple. Someone wondered what happens when gravity becomes infinitely strong. This is the power of curiosity. Another mystery that fascinated Feynman was the behavior of light. At first glance, light seems simple. It allows us to see the world. It travels incredibly fast, about 300,000 kilometers per second. But when physicists studied light closely, they discovered something strange. Light behaves both like a wave and a particle. In some experiments, it spreads out like ripples on water. In others, it appears as tiny packets of energy called photons. Even more astonishing, photons sometimes behave as if they explore multiple paths simultaneously. Imagine shining light through two narrow slits in a barrier. Instead of forming two bright lines on a screen behind the slits, the light creates an interference pattern of alternating bands. This pattern suggests that each photon somehow travels through both slits at once and interferes with itself. To our everyday intuition, this seems impossible, but experiments confirm it again and again. Quantum mechanics, the theory describing these behaviors, is one of the most successful scientific frameworks ever developed. It explains the structure of atoms, the properties of materials, and the behavior of subatomic particles. Without quantum physics, we would not have lasers, transistors, or modern computers. In other words, the digital world we live in today emerged from scientists trying to understand strange experiments with light and atoms. Once again, curiosity led to transformation. And this brings us to one of the most mind-blowing facts about the universe. Everything around you, your body, the air, the ground beneath your feet, is made from atoms that were forged inside stars. Billions of years ago, massive stars lived and died across the cosmos. In their fiery cores, nuclear reactions fused simple elements like hydrogen into heavier ones such as carbon, oxygen, and iron. When those stars exploded as supernovae, they scattered these elements across space. Over time, gravity gathered that cosmic dust into new stars, planets, and eventually life. which means the atoms in your body were once inside ancient stars. You are literally made of stardust. This realization changes how we see ourselves. We are not separate from the universe, we are part of it. The same physical laws governing distant galaxies also shape the chemistry inside our cells. The same atoms that formed stars now form brains capable of understanding those stars. It is one of the most beautiful loops in nature. The universe evolved to the point where it can observe itself, and that observation happens through human curiosity. Today, technology allows us to explore the cosmos in ways previous generations could barely imagine. Space telescopes peer billions of light years into the past. Particle accelerators recreate conditions from the early universe. Robotic spacecraft travel to distant planets. These tools are powerful, but they are still guided by the same driving force that has always propelled science forward. Questions. What is dark matter? What is dark energy? Are we alone in the universe? Dark matter is one of the greatest mysteries in physics. Astronomers discovered that galaxies rotate in a way that cannot be explained by visible matter alone. Something invisible is providing additional gravity. Scientists call this mysterious substance dark matter. Even though we cannot see it directly, it appears to make up about 27% of the universe. Dark energy is even more puzzling. In the late 1990s, astronomers discovered that the expansion of the universe is accelerating. Instead of slowing down due to gravity, galaxies are moving away from each other faster and faster. Something is pushing the cosmos apart. This unknown force is called dark energy, and it may account for nearly 70% of the universe. When you combine dark matter and dark energy, something astonishing appears. Everything we can see, stars, planets, galaxies, and even ourselves, represents less than 5% of the universe. The rest is still largely unknown. In other words, humanity has only begun to understand reality, and this is exactly what excited Feynman. He believed that not knowing something was not a weakness. It was an invitation. Mystery is what drives discovery. If we already knew everything, science would be finished. But the universe is far from finished. In fact, we may be living in the early chapters of understanding. Future technologies may allow humans to build massive space telescopes capable of detecting life on distant exoplanets. New particle accelerators might reveal unknown particles that reshape our understanding of matter. Quantum computers could unlock calculations impossible for classical machines. Artificial intelligence may help scientists analyze enormous cosmic datasets. And one day humans may travel beyond our solar system, exploring worlds orbiting distant stars. But none of these possibilities will happen unless people continue asking questions. Every discovery begins with curiosity. A child wondering why the sky is blue. A student questioning how gravity works. An engineer experimenting with a new idea. These moments may seem small, but they are the seeds of progress. Feynman once emphasized that science is not about memorizing answers. It is about learning how to think. It is about developing the courage to say, I don't know, but I want to find out. And that mindset is incredibly powerful. Because when ordinary people begin exploring extraordinary questions, the boundaries of knowledge expand. The universe reveals new layers. New mysteries appear. And the adventure continues. Today we stand at a remarkable moment in history. For the first time, humanity possesses the tools to observe the birth of galaxies, detect gravitational waves from colliding black holes, and analyze the atmospheres of planets orbiting other stars. Each of these achievements was once considered impossible, but curiosity turned impossibility into reality. And somewhere right now, a future scientist may be looking at the stars for the first time, wondering what lies beyond. That moment of wonder might lead to the next great discovery, because the universe does not reveal its secrets only to a chosen few. It reveals them to those who keep asking questions, those who refuse to stop exploring, those who look at the ordinary and imagine the extraordinary. Perhaps that is the most inspiring lesson from the world of physics. The laws of nature are incredibly complex, yet they can be uncovered by simple curiosity. The universe is unimaginably vast, yet it can be explored by the human mind. And the people who expand our understanding are often not the ones who believe they are special. They are the ones who simply refuse to stop wondering. So the next time you look up at the night sky, remember this. The same universe that created galaxies, stars, and planets also created you. And inside your mind is the ability to ask questions about it. Questions that might lead to discoveries. Questions that might change the future. Because in the end, science is not just about equations or laboratories. It is about curiosity. It is about the excitement of not knowing and the adventure of finding out. Ordinary people asking extraordinary questions, exploring an extraordinary universe, and that journey has only just begun. If you enjoyed exploring the mysteries of physics and the universe, make sure to subscribe to Simple Physics Lab for more fascinating science stories that reveal how our universe really works. New discoveries, mind-bending ideas, and the wonders of space are waiting for you in the next episode.